Hi, and welcome to our course on system administration. Today, in our lab exercises, we'll try to understand hashing with a practical exercise. Now, we'll learn how to generate and verify the hash values for different things. For example, we'll be using MD5 and SHA-1 algorithm in our operating system, which is Kali Linux, and we'll understand the importance of HMAC in ensuring the data integrity and authenticity. Now, in order to start that, first of all, you must have your Kali box open, where you might have a normal terminal. If you want, the first thing you can do is you can go to sudo su and you can log in as the administrator. Once you're done, if you haven't updated the operating system itself, you can check for apt-get and type in update. So that would update any updates which are available for Kali, and they'll be installed on your operating system. Now, once that's done, we'll have to install nano as well. So I'm gonna type apt-get and then I'll install nano, which will be used in order to update the files or to modify them. Now, that's it as far as the basic setup was concerned. I cleared the screen, and now we'll try to start our exercise. So first of all, what we can do is that we can make a directory. So in order to make a directory, you'll have to type in a name as mkdir, and then you can just type in the name. For example, I'm typing in my directory. Now that directory would be created over there. Now, if you want to go to the directory, you'll type in cd and then you'll type in my directory and press enter. So as you can see on top, the path has been changed. So now we are in the directory, which is my directory over there. Now, the next step, what we'll be doing is that we'll have to create a file in this directory, and we'll have to enter some text in it. Now, in order to do that, I'll type in echo and then I'll type in, for example, this is my content, and then I'll close it. And once that's done, I'll press the symbol and then I'll give it a name as file1.txt. So it would create a file called file1.txt, and it would write some text in it, which is this is my content, and then press enter. So now that file has been created on the location. Now the next step is that we'll have to execute it. So in order to do that, I'll type in cat, and then I'm going to write the name of the file, which is file1.txt, and press enter. So you can see the text in the file1.txt, which we have saved in my directory. Now, like similarly as we did file number 1, I'm gonna create 3 more files, and I'm going to save it at the same directory. So as you can see, I passed in the same command, just I changed the content of it. For the second file, I said it's second content, third content, fourth content, and all files are created over there. Now, once that's done, and if you'd like to see the contents of or the files which are created at this destination, you'll type in ls, and it would show you the file 1, 2, 3, and 4, which we have recently created over here. Now, in next step, we would like to check the MD5 hash of file number 1. So in order to check that, I'll type in MD5 sum, and then I'll type the file name, which is file1.txt. So it would tell you the hash code of that file. Now, mind it, that hash code is always unique for every file. It depends that what content is in it, and if you're going to make any changes in it, the MD5 code would change as well. So now I would like to create, or I would like to generate an MD5 hash value for all the text which is included in this one, and I would like to save it in a checklist file, which is a check file. So in order to do that, I'll type in MD5 sum, and then I'll say that whatever file is there, star.txt, and then I'll pass on the symbol, and then I type checklist.chk. So what it would do is that it would generate a checklist including all these files which are available on the same path, and it would show me in a while. Now as you can see, it didn't give me a notification or anything like that, but in order to check that, I'll type in cat and then I'll type checklist.chk. So it should show me all the files which are here, 1 2 3 4, and their MD5 hashes which are listed. Now as you can see that since the text was different in every file, so I have a unique MD5 code for all of these files. Now the next step is that I would like to check the integrity of the files. So in order to check the integrity of the files, you can type MD5 sum, and then you'll pass in -c, and then you'll type checklist.chk and press enter. So it would check the integrity of the files, that all files are fine and they are not being tampered. Now let's try to make some changes in one of the files and see that if this code changes or if it reflects towards the changes that we are going to make in this one. So in order to make the changes, I'll use Nano. Remember, we installed it before starting the exercise, and I'll open, for example, file 2.txt, and I'll press enter. So this was the content of my second file. So what I'm going to do over here is that I'm just going to place a small dot at the end of the line, and then I'll simply close it. It would ask you, would you like to save it? I would say yes, and enter. So it has saved the file on my computer. Now if we would like to check the changes, or if it is able to verify the integrity of the file, we'll type in MD5 sum and then again -c, and then I'll checklist.chk and press enter, and as you can see, it has identified that one file has been changed, and there was a change since we placed a dot in the file, and it showed us this warning over here. Now if we would like to see the MD5 code of it, since the file has been changed, so in order to do that, we'll pass the same command MD5, and then we'll type in sum, and we'll type in file 2.txt and press enter. So as you can see, before on file number 2, we had a checksum which was starting with BD and ending with 440C, and here you can see that the checksum has been changed completely. So that's the main reason why we use MD5 to verify the integrity of the files. Now let's continue with our exercise, and just for the clarity, let's clear the screen. We are going to start working on exploring the SHA-1 and HMAC. Now SHA-1 and HMAC involves understanding how to generate hash values for data and how to use key to create the hash based messages, which is HMAC. It is called hash based Message Authentication Code. We abbreviate it as HMAC for additional security, and the next exercise would involve using HMAC keys. Now in order to start that, I'll use for example SHA-1 sum, which is the SHA, as I told you, SHA-1 and HMAC, and then I'll type in name of the file, for example file 2.txt, and I'll press enter. So as you can see that it has generated a SHA code for file 2 which we created earlier. The next step is that we are going to generate SHA-1 HMAC key, and I'll pass in two different keys, and I'll show you that what's the difference, that even if we'll change the key, what would be the difference in this code which is generated over here. So in order to do that, I'll type in cat, and then I'll type file 2.txt, and then I'll use a piping symbol in between, and then I'll type in open SSL, and I'll type in digest, DGST, and then I'll type in -SHA, which is the SHA, and then I'll type in HMAC, and then I'll type in my key, for example 1 2 3 4 5 6 7 8, and I'll close it over here. Let's check it. It's the file that we have, cat file2.txt, open SSL, DHS, and SHA-1. Just make the modification over here and then press enter. Now you can see that it has generated a key for this one, which is based on the password that we provided as 1 2 3 4 5 6 7 8. Now if I'll pass in the same command again, but this time I'm just going to change the password for 11222334, and I'll generate it. You can see it has generated a completely different key for this one. So that's the function of using HMAC keys. It helps us in understanding that even if the passkey is changed, how big difference does it make in order to generate different HMAC keys for the files. So that was the basic exercise where these steps illustrated the principle of cryptographic hashing function, which is HMAC generation, showing how they can be applied to ensure data integrity and authenticity. By comparing the HMAC values generated with different keys, you can understand the sensitivity of HMAC to a secret key and its role in secret protocols. So that's it for today. Thank you very much.